Hello friends, I'm Anant Pai, founder of Academy in Pursuit of Engineering Excellence. Today we are going to talk about resolution of vectors and its relation with the dot product and unit vectors. Now this is a series of lectures where I'm going to talk about simple concepts. The concepts which we understand, but sometimes we don't give so much of attention to these simple concepts. Sometimes how good we are in a subject depends on how well we know our basics. So today it's all the intricacies of the basics that we are going to see. Okay. So let us start with what is a dot product. Now what is a dot product? Given a vector A and given a vector B. I'll on the pointer, mouse pointer. Okay. Given a vector A and given a vector B. The dot product between vector A and vector B is given by the multiplication of the coefficients like ax, bx, ax into bx plus ay into by plus az into bz. So now what we are going to get is one number. Okay. This can also be done by finding the magnitude of A, magnitude of B and multiplied by its cos. The cos of multiplied by the cos of the angle between those two vectors will also give us the dot product. Now this dot product actually is also called a work product because this is generally associated with force and displacement. So if A is the force vector and B is the displacement vector, the dot product between these two vectors will give us the work product. Also, work is a scalar. Also, when we go with dot product, what we get is a scalar component, or a scalar, what we get is scalar. That's why dot product is also called a scalar. So now let us see much more about these things. Okay. Now what do you mean by resolution of vector? We know what is resolving a vector. So if I have f is a vector and this has to be resolved into x direction and y direction. That means we are going to get the components. So what we get, f is given as fx of I plus fy of j. Now fx is always given by magnitude of this f into cos of the angle here. Similar way, f of y is given by magnitude of this f into cos of the angle beta here. Okay. So this is how we get the resolution of the vector. Now this can also be done in another way. I can say fx is nothing but f vector, that is fx I plus fyj dotted with I. So when I dot I with I, what I get is 1. When I dot j with I get 0, because I dotted with I, the angle between I and I is 0 degrees. So cos 0 is 1, that's why we get this. So fx is f into f dotted with I. Fy is f dotted with j, f vector dotted with j, we get this. Now this concept of this unit vector, using the unit vector, is useful in some of the other places like this. Now in case I have to determine a force F1 given by 10I plus 10J in the direction of another force. When it is in these direction I and J, it seems easy, but when we have to find out the component of force F1, 10I plus 10J in the direction of another force, F2 is equal to 15I plus 10J. Now the problem happens. Now how can we do that? First of all, we can do like this. F12, that is component of force 1 along the direction of the force 2 can be given as F1 cos of the angle between these two. This is one way. Similar way, the component of 2 in the direction of 1 can be given as F2 cos alpha. Now we will see one more thing. See, now whenever I say component, I can actually draw a line from here to here perpendicular. I can draw a line perpendicular here, and this distance from here till here is actually fx. And the distance from here, when I draw a line from this place to this place here, and the distance between here and here is fy. This distance is fy. So now Similarly, over here, if we see, now when I have to get F12, that is nothing but F1, from F1 I have to drop a perpendicular here. So this perpendicular, there's a perpendicular one. Now the distance from here to here, the magnitude is F12. Whereas if I say F21, I have to drop a perpendicular from this line to from this force to another point over here. Now this is perpendicular to this line. This is perpendicular. Now this distance gives me F21. Now here, this can also be achieved by, if I say F12, I can do it like F1 dotted with F2 unit vector. Now when I say unit vector, what does that mean? Unit vector shows only the direction. That means I have to get the force F1 resolved in this direction, in the direction of force F2. So direction of force F2 is determined by the unit vector F2. So unit vector, this unit vector is important. So F1 we are dotting with unit vector along F2. Similarly, F21 we are going to get the F2 vector dotted with F1 unit vector, because unit vector always shows the direction. So that is how we have proceeded. Now to solve this problem, we first find out F2 as the unit vector of F2. Unit vector of F2 we have found F2 vector divided by magnitude of F2 vector, and it is given by F2 is equal to 15i plus 10j divided by magnitude of that. And when I do the calculation, I got this as 0.83205i plus 0.5547j. Now to find out F12, I just have to do F1 vector dotted with F2 unit vector, and then when I did it, I got 13.86. Now when you see F1, this distance would be 13.86. So this is how we find a component of force in the direction of any force. Now unit vector can be given in any direction. To find out the component of any vector in any direction, we have to just find out the dot product of that particular vector with the unit vector that represents the direction. Now one of the things we have to understand here is, again as I did in the previous videos also, now if this is a force, F1 has a unit Newton or any other force units. Here F2 has a unit Newton, but when I say F2 hat, the unit vector F2, it doesn't have any units, because I am dividing it by a magnitude. So now a unit vector of a force in a direction of a force doesn't have any units. So this has a unit, magnitude has a unit, so this can be written as 13.86 newtons. Okay, so I hope you have found something new in this. Okay, these are some things which are very basics, which a number of people understand, but there are few people who don't understand these things. These are directed to the people who have ignored these simple things when they learn. Okay, so thank you very much. Kindly subscribe to my channel and kindly support me by this. Thank you very much.